Hi, we're here today to talk about functional web apps, the revenge of dynamic web apps. So, are dynamic web apps on a rage-filled revenge tour a la John Wick? No, not really. But we are seeing a backlash against some of the other aggressive techniques that have been used to build websites recently. Regardless, I'm getting a bit ahead of myself. First, who am I? Oh, my name is Simon MacDonald. I'm the head of developer relations at Begin. Begin is a small startup where we're trying to make working with AWS a lot easier. If you've ever logged into the AWS console, the first thing that you'll notice is you have to make about 140 decisions before you can get started building a web application. And at Begin, we tried to get everything down to some sane, sensible defaults to get you building applications quickly. Now, if you have any questions about Begin or anything that you see in this talk, please reach out to me at Twitter. My Twitter account is MacDonaldST. It's my old Unix user ID from university, and well, it's pretty much available anywhere on the internet because nobody wants a dumb username like that. But I digress. Let's get back to our talk. So, what is a dynamic web application? Well, I mean, it's not static. The HTML is rendered on demand, but not just the HTML. It could be other things like JSON. And it's completely required for building something like an API. So if you're going to return JSON to a client, you're probably building a dynamic web app. And of course, it's backed by a database. It should be full stack. So this way you have all three tiers already set up for you. And that alludes to the next section, which is the three-tiered architecture. So in a typical three-tiered architecture, we're breaking up our concerns into separate parts. This is sometimes called the model view controller layer, or another way of thinking about it is separating your model or your database side of things from your view, your UI code, from your application logic. And so this allows you to completely separate these concerns so that your frequently changing UI layer is not affecting your less frequently changing business logic layer. And then of course it abstracts the database layer from everything else so that if you actually ever need to swap out your database, you can do it a lot easier. I wish I could ask people for a show of hands right now how many people have swapped up a database on a large application that they built. Usually it's about half of the room. Then the follow-up question is how many people have done it more than once? And it's significantly less than half the room at that point in time. And as well with this three-tiered architecture, we've, have the popular front-end, back-end database engineer roles that come along with it. Now, in a traditional dynamic web app ecosystem, we have a number of tools. Ruby on Rails was very popular. We also have Django, Express, WordPress, and Laravel. I can never say that right, so we're just going to move on because it's not going to get any better than that. So I don't want to really pick on any one particular architecture, but let's use Rails as an example. So they have a very much MVC as well. It's literally MVC. With the active record as the data layer, we have the action view as the presentation layer, and the active controller is the business layer. So this is what the logical application of a Rails app looks like, and that's how we would typically split up the code in one of our projects. Now let's take a look at the physical architecture. So the physical architecture of deploying is a lot different than your source code. This is a typical deployment of a three-tiered architecture, albeit I've simplified it as I've omitted some bits for clarity, but this is roughly what happens when we load balance a fleet of servers to share traffic. These servers will typically talk to a backend database or databases, some for data, some for caching, and then all of these bits can scale horizontally ad infinitum, so in theory as well. Now we'll take a look at the Rails physical architecture. And this is where it kind of gets messed up, is when we deploy our logical architecture, it only goes into the web servers, and then we repeat it as many times as we need to in order to scale for traffic. So the more traffic, the more web servers we need, which means we have to do more deployments. And if anything goes wrong with any of those deployments, we need to roll back X number of servers, and that's a pretty big problem to have. The other big problem is that there are many parts of this architecture that are not in source code control. Places like Heroku took care of that part for you as infrastructure as no code. If you wrote your application in a certain way, all of these other parts were taken care of for you, but over time that didn't scale very well, so tools like Ansible, Puppet, and Chef came around. Configuration manifest tools that would allow you to check in a manifest or a configuration file that describes the infrastructure for you, which eventually evolved into infrastructure as code. Not unlike how we check in a package.json to specify our code dependencies, infrastructure as code allows you to declare your cloud dependencies in something like Terraform or CloudFormation, and now we don't need to wonder how to reproduce this environment or what gets deployed, because it's already checked into source code control for you. So in a traditional dynamic app, there are a number of problems. First off, the three-tier logical architecture is not the same as the physical infrastructure. It's a little difficult to deploy when the infrastructure isn't versioned. You're slow rolling out of all the deployments because you have to hit all those different servers. And then servers are kind of difficult to scale horizontally. And then it's slow to render because the HTML is coming from a traditional database, and they're with the connection-based pooling mechanism that they have, they tend to be a little bit slower than some of our modern databases. Maintenance costs are huge, and it's not fun when you have to be patching, updating, debugging all of these different servers for you. And then when it comes to background jobs that are required in order to give you performance benefits, they're available to you, but they're clunky and bolt-on. So things like pub subs or queues or cron jobs. So all those things are not part of the platform as a whole. Now, if I haven't really convinced you to think about infrastructure as code and how it can help you, I do have a book recommendation for you. And I read way too much, but this is definitely a 5-star book for me. And it's Accelerate. If you've ever read The Phoenix Project, which is another great book, Gene Kim contributed to it. That was a fictional book. But in this case, Accelerate is all of the data that they use to research when writing The Phoenix Project. There is a lot of great insights in this. So once again, 5-star book, totally recommend it. A lot smarter people than me on that one. So moving on from the traditional three-tiered architecture, the next thing that we're going to look at is the JAMstack. So this is where the JAMstack comes in. The idea is to totally build a static artifact by pre-rendering absolutely everything you need and serve it via CDN. Any dynamic functionality will be done by JavaScript at runtime. Well, that's great because the deployment is immutable and nothing is really ever changing. We just mash all of our code together into one giant artifact that is the same everywhere, no matter where it's deployed. And then we get to outsource functionality to a provider that is not part of our business's core competency. So a typical example is something like Auth0 for authentication, as you don't want to worry about authentication. You just want somebody else to take care of that for you. Now let's take a look at the JAMstack logical architecture. Comes out pretty clean. In fact, it's a 2-tier architecture. And there's even an older architecture, client-server, where we used to put all of the application logic on the server and just have a dumb terminal talk to the mainframe. But in the web, we have the client-server where we put a lot of our business logic on the client, i.e. the browser, and make API calls back to our backend server. Let's take a look at the JAMstack physical architecture. Now, the physical architecture turns out to be a bit different, but pretty close to what the logical architecture was. We mix our business logic and presentation code into one artifact, which goes to the client, and then we use network to make API calls to all of our backend servers. Sort of, like Auth0 for authentication or Stripe for payments, etc., etc. That's okay, and it's great because we're only deploying the static assets, but the other parts of the JAMstack are not in our version control, nor are they under any control whatsoever, which is a tiny bit problematic, and we may have seen a story like that somewhere before. Now, the JAMstack has trade-offs. Okay, I'm not saying you should never use the JAMstack. In fact, I've used it myself for quite a number of projects, but you have to consider your use case. So I'm definitely the type of person who will tell you to use the right tool for the right job. So one of the things that I've noticed with the JAMstack is that the builds are slow, and they only get slower as you add more and more content to your site. And now there are some more modern ways that you can take care of that when you're doing incremental builds, or perhaps you're adding some extra dynamic functionality to the website in order to dynamically generate the content, but then you're moving further and further away from what the JAMstack was initially set up to be. And as I said, dynamic is a second-class citizen when it comes to the JAMstack. It's kind of been added in after the fact. So not all tools are going to provide you exactly what you're looking for at this point in time. And there's a complex ecosystem of libraries and tooling and services that you all need to glue together. So you may notice that it's not full stack. It doesn't give you the access to everything that you would typically want in your platform. And it encourages things like spinners and progress loaders and notifications that tell you that the data is coming down because you're having to call into all of these backend services in order to rehydrate your front-end code. And then you need things like Sneak or some other tool in order to make sure that all of your dependencies are up to date. And man, transpiling. Has anybody actually liked transpiling their code? that is notoriously brittle and complex, and it often leads to a bunch of unplanned work that you have to do, because when one of the dependencies that you have in your project gets updated and then just breaks absolutely everything that you have in your toolchain. And then it's kind of creating this asymmetry between the infrastructure and the code, because they are completely separate at this point in time. Now, you may have heard of the rebound effect. In conservation and energy economics, the rebound effect is when you don't actually get as much of the gains as you're expecting to. So you may expect to get some huge gain from some new technology, but what you're actually seeing is because there's the gain, which makes the use of the resource a lot cheaper, then people end up using more of it. So you don't get the overall effect that you were hoping for. It definitely does give you more beneficial effects, but again, not as much as you're hoping. Now, I'd like to coin something today, and it's called the JS rebound effect. And that is basically the expected gains you get from a new JavaScript framework is always less because of the amount of JavaScript that gets deployed to the client. All of this additional JavaScript diminishes the beneficial effects of the new technology, and in some cases makes it even worse, because the more JavaScript you send down to the client, the more that has to be downloaded, it has to be parsed, it has to be run on the client. Sometimes you're better off with like simpler solutions than just more JavaScript. And this is from somebody who, paid for their house writing JavaScript for many years. And so we'd like to introduce you to a new approach of working on these things, and that is the FWA, or the functional web app. So the entire thing is HTML first. You get the dynamic personalization, and accessibility is completely a priority. So everything is cloud function centric. The entire system is pure cloud functions from front end to back end. That includes rendering HTML on demand. So server-side rendering of your HTML. It's full stack. Most of the capabilities are built in. So if you are looking for things like queues, events, and cron jobs, those are built into the platforms that you can build functional web apps on top of. You have on-demand databases as well, and with on-demand databases, you get auto-scaling. There's no socket connections to these databases, so you don't have that performance hit as you add a new socket connection to the database. As well, they handle all of the scaling of the database for you, and they guarantee single-digit millisecond latency. So the speed is just intense when it comes to these new versions of databases that we have. And then for deployment, we use declarative deployment. It's explicitly defined as infrastructure as code. There's a bunch of different ways to do things like this. It could be CloudFormation, could be Terraform, etc., etc. But these are kind of the 4 pillars of a functional web app approach. So let's take a look at the functional web app's logical architecture. So the logical architecture, what I just described, is this. You put the presentation layer and the business logic into Cloud Functions, and they talk back to the data access layer. And you're probably thinking at this point, this is a terrible idea. But let's take a look at the functional web app physical architecture. So it comes out pretty similar to the logical architecture. There's still a CDN and static assets so that if your web app has a build step, you can have a place to deploy these files, even though you don't need to if you don't want to. All of this functionality can scale out horizontally as you need, and it all talks to this backend database. What's nice about it is your deployment is the entire thing. So you get one entire declarative, fully deterministic artifact. If you ever need to roll back to a known good state, you can do so with a high degree of confidence. So comparing the two, if you look at them side by side, you can see which parts are deployed. On the JAMstack side of thing, you're basically just deploying your CSS, HTML, and JavaScript that you've built at build time to a CDN. And over on FWA, you are kind of tagging the entire thing. So your HTML, your CSS, your JavaScript, your database, your backend code, they're all in one package that can get deployed. And that you're just going to get a better experience with this type of architecture, in our honest opinion. And how do you get a better kind of performance out of this architecture? Well, let's take a look at some of the advantages. The first thing is you have access to the entire stack. So front end, back end, middleware, everything is available to you. The second thing is it's a lot more fun. You spend a lot more time writing code and solving problems, and you spend a lot less time maintaining things, and you just spend more time shipping code. I mean, this is going to sound bad, but I used to love React, and I totally believed it when it said it would improve my developer experience. And I have to tell you, I was happier with React for a while. It's always more fun to be solving problems than to be working on ceremony. But over time, I mean, anybody use Angular? Angular 1, hands up, anybody? We all wrote our applications using Angular 1, and then they released Angular 2, and then we all had to rewrite our applications to use Angular too, and we were all very mad. We had everybody at that point in time at Google, and that was too bad. And sadly, React is kind of doing the same thing. I mean, they moved from, the create element API into doing class functions, into doing functions with hooks. And it's like the way that we wrote React 4 or 5 years ago is completely different from the way that you do things today. And do we need to continue to move forward with some of those things, or are those just unplanned bits of work that we are just kind of doing because some large company says that we need to? So I'm kind of at the point now where I just like to focus on the business logic instead of maintaining dependencies. You move a lot faster, and you actually ship things instead of treading water, constantly keeping yourself up to date with the latest version of the JavaScript framework that you have picked. And you're not dealing with breaking changes in other people's code or unplanned work because of these things. So the final bit is you're not really hiding any kind of dynamic content behind a spinner that may load. Because what happens when you're using functional web apps is that first delivery to the client side is HTML, and it's fully workable to the client at that point in time. Even if they don't have JavaScript involved, they can still interact with the page, which I know is mind-blowing that you can actually use the web without JavaScript, but you can. And a lot of times it's a lot faster because you don't have to wait for the JavaScript to download and to get interpreted. Now, it wouldn't be fair if we didn't talk about some of the problems that we have, and one of them is cold start. You're probably all wondering, like, oh, what about cold start? So, yeah, we find that the best way to combat the cold start problem is with small, single responsibility cloud functions. We've known for a while now that it's the large code footprint that correlates with longer code starts. So the more code you have to parse at the startup of your cloud function, the longer the cold start will be. So we found a good rule of thumb is to keep the payload size below 5 megabytes, which keeps the cold start under 1 second and frequently under 200 milliseconds. If your cold start is over a second, your cloud function is probably too big, or in some cases, and weirdly enough, we've seen some pretty inefficient code that we've downloaded from NPM. And in that case, you can do one of two things. You can split it up into multiple cloud functions, again, single responsibility, or you can do some pre-provisioning of capacity depending upon what cloud provider you're using. The database story is still emergent at this point in time. We have a number of wonderful options that you can use for these modern databases. DynamoDB, Cosmos, Planetscale, Fauna, they're all available to you. And they have great performance no matter how much data that you have. And it's wonderful. You don't have to think about your data layer anymore. And you don't have to worry about upgrading it in the background. Somebody's going to take care of that for you. And I got to tell you, I've never taken a course on databases in my life, and I'm pretty happy with that. And I would like to keep that going. Doing declarative infrastructure as code can be often very complex. I don't know if you've ever seen CloudFormation. It can be a bit scary. So much so that we wrote our own terse format called Arc in the Architect open source project to make dealing with CloudFormation a lot easier. I will show you an example in a moment where we have like a 10 line Arc file, which blows up into about a 1400 line CloudFormation file. So you can easily hand maintain the 10 line Arc file, but a 1400 line CloudFormation file, good luck. Not for me. Anyway, the other thing that we would suggest is you go all in with managed services with one cloud provider. So it's no good if you mix AWS with Azure or with Google Cloud. Really, you want to pick one of these clouds and stick with it. Things aren't very portable between the clouds just yet. So an AWS Lambda is not an Azure function, which is not a Cloudflare function. So if your primary goal is to be portable with these types of things, then you probably want to look at using Kubernetes instead. Personally, I think you should pick a cloud provider and just go all in with it. We use Amazon. We're very happy with it. I don't think AWS is going anywhere anytime soon. And they have this wonderful thing where they don't actually ship breaking changes. So we can be sure that something that was written 8 years ago in AWS will continue to work today. And that means there's a lot of things that we don't have to worry about, having to change our code just because some dependencies under the hood changed as well. So there's a growing ecosystem of things out there that you can use in order to build functional web applications. And I'm sorry if I've missed yours, but there's a number of them here. OpenJS Architect, which is the project that I work on. You can build right on top of AWS or Azure. Begin, again, is the company that I work for, that we make these things a little bit easier for you. We could also use Cloudflare or Deno or GCP, And if you know of any other things that I've missed, please contact me and I will add them to the system as well. So does anybody actually do this in the wild? And it's like, yeah, they do. Some functional web apps in the wild. We have the BBC. They spent a little bit of time completely converting over their entire site over to a functional web app approach. Other companies like a Cloud Guru and Bustle, and of course Begin. We do like to drink our own champagne, so any of our applications are built using the functional web app paradigm. So we're really all in on this as well. When it comes to static apps versus a functional web app, we kind of look at this as being a modern architectural pattern for dynamic apps. I mean, static apps are great, especially if you don't need dynamic content. But once you do, you kind of need to look for a completely different architecture. And I think FWA is what you may want to look at next. Everything is HTML first, and then we use progressive enhancement. So it doesn't matter if JavaScript isn't enabled or if it fails to download. By putting HTML first down to the client, then things are just going to work no matter what happens. I remember there was a story not too long ago about this poor woman who wasn't able to register for her COVID vaccine because her browser didn't support whatever new JavaScript functionality there was. And you got to ask yourself the question, do you really need JavaScript to enter form data in? It probably didn't need to be that way. Anyway, Cloud Functions Centered Development Model. I think that this is very overdue. There's databases that are completely built in. Absolutely just a delight to work with at this point in time over speed and not having to worry about managing them. And then, of course, there's the declarative deployment, infrastructure as code. If you aren't checking in all of your dependencies, like how do you know that you can actually reproduce your application after the fact? That's kind of scary if you don't have that into source code control. So let's just do a quick demo. A very simple to-do list application where we're going to create some to-dos and edit them and delete them. In order to get things going, we're just going to start a new terminal here in Visual Studio Code. It's going to type npm start. And that's basically just going to start what we call Architect's Sandbox. It's a way of doing all of your development locally. This way you can do most of all of your work on your local machine before you even have to deploy to the cloud. So what we have now is a site running on localhost port 333. And if I just go over here, let's just refresh this page. Yeah, everything's working fine. So let's make our to-do. Let's call it the first to-do. And there we go. Now we've created a new to-do. Let's go to a second one. All right, so that's great. Things are working pretty good. Let's just go ahead and edit this guy. I know it's not the most original to-do item names, but let's just say, all right, we're gonna complete that one, and we'll complete this other one. And it's like, hey, we've got all our to-do lists done, and just delete that one. So there you go. Very simple functionality with create, updating, and deleting to-do list items. Now the question is, how do we do that? Well, let's take a look at that app.arc file that I promised you we would take a look at before. And you'll notice there's a few things. First, the name of the app, CRUD app. Not very unique, but that's what we have. And then we have this static pragma here where we say that the folder that our static files will be in is public. So anything that's under the public folder here, our 404 page, some of our images, all of that will get deployed to an S3 bucket that the architect will automatically create when you go to deploy. As well, fingerprint is true. So what's happening there is any of these static assets will get a hash appended to the end of the file name, so that if you update your 404 page or your background JPEG to a new version, the hash will be recreated. So that way, anything that gets deployed to your static bucket is going to be up to date, and it'll be able to break out of any kind of browser caching to make sure that your users get the most up-to-date stuff. Then this section here under HTTP, we're creating a bunch of lambdas to handle HTTP requests. So for getting to-dos, posting a new to-do, deleting a to-do, or updating an already existing to-do, we're going to create these 4 different lambdas. So let's just take a look at the posting of a new to-do. We're going to require the architect functions package as well as begin data. So architect functions gives you a lot of helper functions in order to be able to do normal tasks. Like for instance, right here, we're going to get in the request, and then it's going to parse the body for us so that it changes the form data into just a nice JSON JavaScript object that we can work with. And from there, we're just going to add a created date because this is a brand new to do, so we need to know when it's been created. And that'll become important when I talk about the DynamoDB time to life section. Anyway, so we set this using begin data. Begin data makes life a lot easier for you to be working with DynamoDB for its APIs. And then finally, we'll redirect back to the main root of the application so that you can see the latest updates to your to-dos. So back over to app.arc, you'll notice the last section here is on tables. So we're going to have a data, and we have our scope, our data ID, and that time to life. So when we create that to-do list item, we can actually specify how long we want that data to kick around. So that way, if you're having a lot of transient data like tokens for authentication, you can automatically expire them, and any of them that are stored in the database. So what we have here is about a 19-line file for app.arc. So again, very terse format, not a lot of things to maintain. And you have created an S3 bucket for all your static files, 4 AWS Lambdas to respond to HTTP requests, and a DynamoDB instance with your data in it. So that's pretty good. What does that look like when you're using SAM CloudFormation? Well, good thing you asked. So you can see that this file, he taps out at line 729 here. That is a pretty huge file, and it's not terse at all. In fact, it's very verbose. And I can't imagine what that would be like editing by hand, so I'm really glad that we have the architect format. Anyway, that's just a super quick tour of some of the things that you can do with the Architect open source project. And if you want more information on that, go to arc.codes and you can learn more about it. All right, back to the slides. Now, where can you learn more about functional web apps? Well, if you go to fwa.dev, you can read more about the architecture pattern itself. If you want to get involved in the open source project that I talked about, Architect, it's on github.com/architectarchitect. And if you just want to try out something very simply using our web interface, you can go to begin.com. All you need is a GitHub user ID. There's no charges on how to get started with this thing, but you can deploy your first functional web app using Begin. And then, of course, please tell me how wrong I am. I love hearing from other people. So anyway, thank you so much, and I hope you all had a wonderful conference.